Hi, so in this video we're going to be talking about the equation of the perimeter and the area and the volume and the surface area of a variety of different 2D shapes and 3D shapes. To begin, and then we'll be talking about Pythagorean Theorem as well when it comes to triangles. So to begin, we'll be talking about perimeters. A perimeter, when you're thinking about it in real world examples, is basically the length of fencing that you're going to need around a certain shape of land. So to begin, we'll start with the circle. Circles have a special word for the perimeter of the shape. It is going, they call it the circumference. And the reason why the formula for a circumference is 2 pi r. And the reason why it's 2 pi r is because if you take your diameter, and a radius is half of the diameter and can also be seen as the center to the end of a, from the center to one of the sides. A radius is half of a diameter, but if you take your diameter and you stretch it around the circle, it fits almost 3 times, but there's this little gap in between, and that gap is basically how we came up with the concept of pi. So pi is 3.14, 15, blah, 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 blah. It's an irrational number, so it goes on forever. It basically says that you can wrap the diameter around a circle pi times. And so a diameter is 2 times the radius, so 2 pi r, or 2 times the radius. And then you'll times it by pi because that's how many times it will go around. For the reason why the area of a circle is pi r squared, I'll link a video that explains it a little bit better than I can. But you will need to know all of these formulas. For rectangles, the perimeter is going to be 2 times the length because there are 2 lengths that are the same, and 2 times the width because there are 2 widths that are the same. The area is going to be length times width, because if you have a rectangle and one side is 3 and one side is 2, typically they'd be more even than that. I just didn't draw it out very good. There's 6 different squares on the inside. 2 times 3 is 6. Basically, you're thinking about it in a 2D space. For triangles, the perimeter does not have a easy, happy perimeter equation. You're just going to have to sum this length of the sides together. For the area, the reason why it's 1/2 base times height is because if you take any triangle, I deleted my little triangle from earlier. Hold on. So for a right triangle, the height is going to be the longer side, but not, well, it doesn't matter which one is the height as long as you're consistent. It's not going to be this here because that's hypotenuse. I was blinking. It probably could, just as long as you're being consistent with things. But it already gives us basically an easy height. So if we take our right triangle and we duplicate it, and we flip it over and line these heights up to be parallel with each other, it'll give us a square, or a rectangle in this case, in most cases. So height, and then this was also the height, and you want them to be parallel. And so you're doubling it, however, the base and the height stay the same. So when you're thinking about just that one single triangle, it's going to be 1/2 base times height because you aren't doubling it in this case. For triangles that are not right triangles, if you have this, where I already drew the height line, and you take it and you duplicate it, hold on, and then you flip it and have it so the heights are parallel, you have a parallelogram, and parallelograms are still base times height. for the area. And the reason why that is because if we take it even further and take this 1/2 of the half and move it over here, it basically just turns into another square. And we doubled it. The base times height. So it's base times height and then 1/2 because we doubled it. Sorry, I lost track. And then, so hopefully that makes a little bit of sense. Basically, you can double the shapes and flip them. Which layer is that on? Oh, it's already there. So then I double that and flip it. And the heights need to be parallel. And we gotta tilt it a little more, and then it'll be a parallelogram again. And since we doubled it, well, it'd be base times height, and then a parallelogram. Yeah. And then, sorry, I just realized that this explanation could have been a little bit more confusing. So I'm going to just re-demonstrate this. Whoops. You flip it, so the heights are aligned because we're choosing that as a height. And then the base of the triangle and the height is going to be where we're timesing to get this, and then 1/2. Hopefully that makes sense. Then for the trapezoid, same case with the triangle, where you're going to have to sum sides. They don't all have the same sides each time. So the formula for the area of a trapezoid is 1/2 height base times base 1 plus base 2. And if we look at this, it'll be, we have our trapezoid. So here's this. Our height is always going to be like that, basically, how tall it is. And then this is going to be base 1, base 2. And then if we, well, this one's a little bit more tricky to explain, but it's like the same sort of principle as the triangle, where you have like the triangle and then you put it over on the other side. I'll link a video that explains that a little bit better as well, because it's a bit hard for me to explain that one. When it comes to triangles, you might not always have what the height is going to be or what all sides are going to be. We have a nifty tool called the Pythagorean Theorem that can help us with that. Now, the Pythagorean Theorem only works on right triangles, which is a triangle with a 90-degree angle. And basically, it says a squared plus b squared equals c squared. C squared, or c, is always going to be the hypotenuse. A and b are pretty interchangeable as long as you keep them in track, like when you're doing the formulas. You can assign either to A or B. Now, to do this, say that we have something like this is 4, and this is a 3. Actually, we'll do 3 and 4. 3 squared plus 4 squared is equal to c squared. 3 squared is 9 plus 16 is equal to 25. So 25 is equal to c squared. And then to get c by itself, we're going to square root. And the square root of 25 is 5. So this side would be 5. This is, Pythagorean Theorem only works for those with right angles. I know I've said this already. Right triangles. Yeah. If you knew that this side was 5 and you didn't know that this side was 4, you can pretty much play plug-in. So, let's say 3 squared is equal to b squared, plus b squared is equal to c squared. And we want to get b squared by itself. So let's minus c squared over and minus b squared. So, or here, one sec. Actually, it's easier if we move this 3 squared over. So b squared is equal to c squared minus 3 squared, which is 9. Which will give you, oh, and sorry, we already knew c squared, which is 5. You basically want to play plug-in and solve for the variable that you don't know. So this is going to be 25 minus 9 is equal to b squared, which is 16. So b squared is equal to 16. Square both sides. This will give you 4. This is just a really useful method for finding a missing square side to a right triangle. Yep. Hopefully that makes sense. Now we'll talk about 3D shapes. I don't need this up there. So we have our 3 typical shapes that you'll see in the homework, which is a right side, not right side, sorry. Maybe it is right side. A right cylindrical prism. One second, I have to remember what the actual official term is. Right side cylinder. Yeah, right side cylinder. You don't need the prism part. It's a right side cylinder. So the volume, and this is going to be a pattern in all 3D shapes that are right side, which means that the base on the top and the base on the bottom is the same. So it's going to be the area, which is pi r squared, times the height is going to equal our shape. And if we think about a 3D shape, like a Rubik's Cube, but we'll just do a 2-sided Rubik's Cube. When we have a Rubik's Cube that has 2 by 2, and then 2, 2, I'll actually do that in a lighter blue. That looks kind of gross, but we'll deal with it. And then we go that way. Oh, and I want this to be that way. That way. That way. That way. And then if we take this blue, do that, do that, do that. It looks kind of gross, but we know that if it's a 2 Rubik's Cube, there's going to be 1, 2, 3, 4, 5, 6, 7, 8. There's going to be 8 cubes inside of there. Basically, which is the same as our base, which is 2 times our height, which is 2 times our width, which is 2 in this case. If it was something like 3 times 4 times like whatever, that'd be a different story. Hopefully that makes a little bit of sense. Sometimes I can get lost in the weeds with things. But basically the volume is pi r squared times height. So we're basically just stretching our base and extruding it, and yeah. The surface area is going to be 2 pi r squared, which is the area times 2. And then plus, sorry, 1 second. Our circumference times our height. Sorry, I was getting distracted by drawing this. And the reason why that is because if you unwrap and this is not going to be perfect, but if you unwrap a cylinder, a right-sided cylinder, it looks sort of like this, right? Like if you go into your bathroom and look at your toilet paper, it's going to look something like this when you unwrap it. Like if you have the top here, and then the actual toilet paper in the middle. It's a rectangle in the middle, and the rectangle is going to be the length of the perimeter of these circles, and then it'll be times the height, because we want to find the area of each piece. So yeah, if you unwrap a rectangle, like a rectangular prism, you basically get something like this, except for the sides would be a little more even. Where there's 6, or the sides would be more accurate, I guess, not even necessarily. But there's going to be 6 different faces. And for cubes, you can just times each of these areas, each of these faces by 6. Well, one of these faces by 6, because that will give you each side. But when it comes to the surface area, you're going to add these. So these 2 sides are going to be the same. These 2 are going to be the same. And these 2 are going to be the same. I'm pretty sure. It might be wrong when you're folding it out, but basically it's going to be your base times width, and your base times width. So 2 of those, and then 2 of your base times heights, and then 2 of your width times heights, when you think about it like this. So base times width times height. And so for volume, then you add those all together. And then for volume, it's going to be base times width times height. And we kind of went over that with the Rubik's Cube. The height in this one is going to be the same sort of like principle. And we've already talked about how the volume is going to be the base's area times the height because it's being extruded. So 1/2 base times height is our area of this times our width. Or, well, I guess it'd be like base times height and then by length. And then for the area, this one doesn't have like a really easy formula either. Because if you have a rectangular prism, 2 of the sides could be different. Or all sides could be different. You only have the 2 bases that are going to be the same on a right side triangular prism, but it's going to be your base, 2 of your areas of these triangles, and then the area of this one, the area of this one, and the area of this face, which are, those 3 are rectangles, so it's going to be base times length, base, I don't know, like all of those. It's going to be, you just basically have to work that one out a little bit more with no easy formula. This video got kind of long and I apologize. I get really wordy sometimes. If you have questions still, I hope this didn't confuse you more, but if you have questions, please let me know and I'll try to condense this information. Thank you.